Hello students, welcome to memoneet. This is Ravikant, a physics teacher, and today here we are going to discuss your BPD 16 question paper, which was related to rotational motion. And let's see, straight away go to the question number one. The question number one says that the angular velocity of a body omega as a vector form is given as 2I cap plus j cap plus 5k cap radian per second under a torque tau is equals to 5 cap plus 2j cap plus 3k cap Newton meter acting on it. The instantaneous rotational power for rotational motion power is being given to us. P is equals to tau into omega, right? That is tau vector dot omega vector. So tau vector dot omega vector has been done over here for you. That is 5 cap plus 2j cap plus 3k cap. When dot product with 2 I cap plus 5 plus j cap plus 5k cap, it will give you 27 watt, right? So the correct answer for your question number one is 27 watt. Next, coming to question number two. Question number two says that a conducting ring of mass 1 kilogram and radius 0.5 meter is placed on a smooth horizontal plate. The ring carries a current of 8 ampere in horizontal magnetic field. B is equals to 5 Tesla is switched on at t is equals to 0 as shown in the figure. The initial angular acceleration of the ring will be, right? So the initial angular acceleration. So first you will calculate the torque on the ring. Torque on the ring is given as tau is equals to I A cross B. That is tau is equals to M vector cross B vector, right? Where your M vector is equals to I into area vector. Putting the values, I is equals to 8, area is equals to pi r square into B and sine theta, that is angle is 90 degree. We get torque on the ring as 10 pi Newton meter, right? This was according to the magnetism. But according to rotational motion, tau is equals to I into alpha, right? I is the moment of inertia of the ring and alpha is the angular acceleration. So for a ring, moment of inertia about its axis is given as mr square by 2. Putting this mr square by 2 in place of I, we get tau is equals to mr square by 2 into alpha. Equating both the torque, that is torque which we calculated using the rotational motion concept and the torque which we calculated using the concept of magnetism. Both the torques are same, right? So equating them, finally we get alpha is equals to 8 pi radian per second square, right? So your angular acceleration here will be equals to 80 pi radian per second square. So the correct answer for question number 2 is your option number 3, right? The true formula which we've used over here is tau is equals to your M vector cross B vector. This is from magnetism, where M is the magnetic moment of the coil, B is the magnetic field applied, and from rotational motion, tau is equals to your I into alpha, where I is the moment of inertia and alpha is the angular acceleration. Equating both the torques will get the value for alpha, and that alpha is equals to 80 pi radian per second square, right? Now let's come to question number 3. Question number 3 says that two persons of mass 555 kg and 65 kg respectively are at opposite ends of a boat. The length of the boat is 3 meters. The weight and weighs 100 kilograms. The 55 kilogram man walks up to a 65 kilogram man and sits with him. If the boat is in still water, the center of mass of the system shifts by. See, from here, from the scenario, what we find that if this is the boat, one man was sitting here and another man was sitting here, right? What happens? One man stands from here and walks to this man. What is happening? The motion or whatever being is done within the system, right? So there is no external force or no external torque acting on the system. Therefore, by law of conservation of linear momentum or angular momentum, net external torque or net external force is equals to 0. Therefore, there will be no change in momentum, and hence the center of mass will not be in motion as it was initially at rest. So if center of mass is in rest always, so they are asking you if the boat is in a still water, the center of mass of the system shifts by. It does not shift. The correct answer will be option 1. Why it does not shift? Because all the actions are taking place internally. So no external force has been applied on the boat or on the system, and because no external force is applied on the boat, momentum is conserved. If momentum is conserved, it means there is no motion in the center of mass, right? And the center of mass is not moving. That means the shift is equals to 0. So the correct answer is option 1, right? Now let's coming to question number 4. Question number 4 says that a hollow spheric sphere of mass m and radius r rolls on a horizontal surface without slipping, right? Without slipping, such that the velocity of the center of mass is v. The total kinetic energy of the sphere is. See, when the this is the case of basically rolling, right? When the object is rolling, it will possess two kinetic energy. One is your translatory kinetic energy, translational kinetic energy. Other will be your rotational kinetic energy. Translatory kinetic energy is given by half m v square, and rotational kinetic energy is given by half I omega square, where I is the moment of inertia and omega is the angular velocity. Right? Now, for a pure rolling, because the case of rolling, for pure rolling, v is equals to omega r. That is translatory velocity is equals to angular velocity into r. Right? So rotational kinetic energy is equals to 1 by 3 m v square. Now to stop, yes, to stop the sphere completely, the work done will be equals to total kinetic energy, translatory kinetic energy plus rotational kinetic energy. The translatory kinetic energy is half mv square and rotational kinetic energy is 1 by 3 mv square. How we got 1 by 3 mv square? Because rotational kinetic energy is half I. I for this hollow sphere is 2 by 3 mr square. So this 2 and 2 cancels out. What we have? We have half into I. I, there is moment of inertia of hollow sphere, which is 2 by 3 m r square, right? Into omega square, and omega is written as v by r, right? Or we can write it as omega square itself, v by r. So this r and this r cancels out. This 2 and this 2 cancels out. What we are left with is 1 by 3 m r v, m r v square. Here it's also says so omega square होगा ना, हाँ तो square cancel out. We don't have any r over here. It is equals to 1 by 3 m v square, right? 1 by 3 mv square is the rotational kinetic energy, and 1 by 2 mv square is the translatory kinetic energy. Sum of this will result in 5 by 6 mv square. So the correct answer for question number 4 is 5 by 6 mv square. That is option 3, right? That is option 3. Now let's come to question number 5. Question number 5 says that from a circular ring of mass m and radius r and r corresponding to 90-degree sector is removed. The moment of inertia of the remaining part of the ring about the axis passing through the center of the ring and perpendicular to the plane of the ring is known. Ring is k times mr square. Then the value of k is. See, when the 90-degree sector has been removed, that means 1/4 of the ring has been removed. It means if total mass was m, the mass left is 3 by 4 times of m, right? And this mass is being rotated about the radius, which is equals to r. About the radius, which is equals to r. So the moment of inertia I will be equals to m, that is 3 by 4 m, r square, that is r square. So initially it had moment of inertia as mr square, right? It had the moment of inertia mr square. So the factor with which it has been changed is 3 by 4. So the correct answer for this question number 5 is 3 by 4, which is in option 2. Right? Getting my point? This mass had this moment of inertia as m r square. When mass is removed, it had its moment of inertia as 3 by 4 m r square. Right? So the factor with which it is changing is 3 by 4. The correct answer is your option 2, right? Now next coming to question number 6. Question number 6. It says moment of inertia of a uniform cylinder of mass m and r about its geometrical axis is. So moment of inertia of a solid cylinder of a uniform cylinder is mr square by 2. So it's mr square by 2. Mr square by 2 is option 1. So you have to remember this formula, otherwise the derivation is there. You can see the derivation, but derivation is not in your syllabus, right? So directly from the formula, if you remember that is the moment of inertia of a uniform cylinder about its axis. Suppose this is a cylinder, then its symmetrical axis is your axis passing through the center, right? So about this, the moment of inertia is equals to 1 by 2 mr square, which is equals to the moment of inertia of a ring. So the correct answer for question number 6 is option 1. Now let's see question number 7. Question number 7 says that when a man stands on a turning table stretching with two equal loads in the hand and rotates, then he folds his arm. Which of the following statement is correct? The linear momentum is conserved, time period increases, angular momentum increases, angular velocity increases. See, when it is moving uh, with her arm stretched and then the arms are folded, there is no external force acting on the body. There is no external force acting on the body. If no external force is acting on the body, there is no net torque is equals to 0. It means the angular momentum, that is L, is equals to constant, and angular momentum is given by I into omega, right? So I into omega, that is I1 into omega 1 is equals to I2 into omega 2, right? I1 is when the arms were stretched, and I2 is the moment of inertia of the body when arms were brought close to the center, right? The arms were folded. So when arms are folded, the value of R decreases. Now if value of R decreases, I2 decreases. When I2 decreases, so to maintain this product as constant, omega 2 has to increase, right? So if I1 is the moment of inertia when the arms were stretched, and omega 1 was the angular velocity in that case, and then when the arms are folded, the moment of inertia is I2, and because the arms are folded, the distance of the mass from the axis reduces. Therefore, the moment of inertia reduces, and when moment of inertia reduces, to keep this product constant, omega 2 has to increase, right? Therefore, omega 2 will increase, and according to this, the correct answer will be option 4, that is the angular velocity will increase, right? So, the correct answer for question number 7 is option 4. Now coming to question number 8. The ratio of radius of gyration of the solid sphere of mass m and radius r about its own axis to the radius of gyration of the solid cylinder of same mass and same radius. So moment of inertia is given as I is equals to mk square, where k is the radius of gyration over here, right? So for a solid sphere, I is equals to 2 by 5 mr square, right? So if I is equals to 2 by 5 mr square, then here k will be equals to under root of 2 by 5 r, right? Then we have a solid cylinder. For solid cylinder, we have I is equals to mr square by 2. So if I mark it as K1, I1, then for a solid cylinder, I2 is equals to mr square by 2. So from here we get radius of gyration K2 is equals to 1 by root 2 into r, right? So when we find the ratio K1 upon K2, what will happen? This root 2 will go up, multiply with this root 2 will become 2. So the ratio will be equals to 2 is to root 5, right? So the ratio will be equals to 2 is to root 5. So the correct answer for question number 8 is option 3, that is 2 is to root 5. 2 is to root 5, right? Now next come to question number 9. Question number 9 says that the particle of a mass m is projected with a speed of u at an angle theta with the horizontal. The magnitude of the torque on the particle about the point of projection when the particle is at the highest point. So a particle has been projected at angle theta, it will form a parabolic path. They are asking you torque at this point, right? They are asking you torque at this point. So the only force acting on the body at this point will be its mass m into g, right? And this is the point about which they are asking the what? Asking the torque. So the if this is the line of action, then the perpendicular distance is this, and if this is the perpendicular distance, this is basically range of the projectile by 2, right? And range of the projectile is being given by the formula u square sine 2 theta upon g. So the distance between the line of action and the fixed point is r by 2. So r by 2 will give you u square sine 2 theta upon 2g, right? U square sine 2 theta upon 2g, and the force is equals to mg. So here you can see that torque is equals to, this is mg, which is force, and this is the perpendicular distance u square sine 2 theta upon 2g. Multiplying this, we will get tau is equals to m u square sine 2 theta upon 2, and we can write this as mu square sine theta cos theta, right? Why? Because we are getting here is mu square sine 2 theta upon 2, and sine 2 theta can be written as mu square 2 sine theta cos theta upon 2. So this 2 and this 2 cancels out. What we are left with is mu square sine theta cos theta, which is our option 1. Right? So the correct answer for question number 9 is option 1, that is mu square sine theta cos theta. Next, coming to question number 10. Yes, question number 10. Question number 10 says that a merry-go-round rotates from rest with a constant angular acceleration alpha. Ratio of time to rotate first 2 revolution and the next 2 revolution is. So it is starting from rest. So the angular rotation for one revolution is given as 2 pi, right? 2 pi radian. Now using the formula theta is equals to omega t plus half alpha square t. It is angle analogous to s is equals to s is equals to ut plus a t square, right? So in place of s we here write theta omega t plus half alpha t square, right? This is the formula that we are using. So for first 2 seconds, theta 1 will be equals to, because omega initial omega is 0, so this becomes 0, so we'll get 2 into 2 pi, right? Theta is equals to, for first 2 revolution, theta 1 will be equals to 2 into 2 pi, that is 4 pi, right? So for first 2 revolution, if theta is equals to 4 pi, putting the values in the formula, 4 pi, that is theta, is equals to omega t plus half alpha t1 square, right? So from here we get t1 is equals to 8 pi under root 8 pi upon alpha. Now for the first 4 revolution, theta will be equals to 8 pi, putting theta as 8 pi omega t plus half alpha t square. Now here we will get t dash whole square. So now t dash, that is the time taken for 4 revolutions, is equals to under root 16 pi alpha. So the time for 2 revolutions which occurred after the first 2 revolutions is t dash minus t1, that is under root 16 pi alpha minus 18 pi alpha, and this will be equals to under root 18 pi alpha into root 2 minus 1. Now when we find the ratio of t1 is to t2, it will be equals to under root 2 plus 1 is to 1. Under root 2 plus 1 is to 1, which is option 2, right? Why? Because we had our t2 is equals to under root 8 pi upon alpha, and t1 is equals to 8 under root 8 pi upon alpha into root 2 minus 1. So finding the ratio, we will get 1 upon root 2 minus 1. Rationalizing it, that is multiplying with root 2 plus 1 upon root 2 plus 1, we will get root 2 plus 1 upon 1. So the ratio is root 2 plus 1 is to 1. So the correct answer is option 2, right? Now let's come to question number 11. Question number 11 says the time varying torque 8 kN is applied on an object about pivot angular momentum of the body at time t is equals to 2 seconds, right? So the torque tau is being given as dl by dt. Rate of change of angular momentum is equals to torque applied on the body. So from here we can say tau dt is equals to dl. Integrating both the sides, we will get L is equals to integral tau dt, right? And tau is what? 8t. So integrating 8t, we will get L is equals to 4t square. And what we have to put t is equals to? T is to be placed as equals to 2. So putting t is equals to 2 here, we will get L is equals to 16 kg meter per second, right? So the correct answer for question number 11 is option 2, that is 16 kg per kg meter per second square, right? If we want want the clarity for integration, so we are integrating here is integrating 8t dt, right? So it will be equals to 8t square upon 2. So this 2 will cancel out and this is 4. So this is equals to 4t square. So integrating 8t will get 4t square, right? Now next come to question number 12. Question number 12 says that a uniform thin rod of length L and mass M is hinged at one end and released from the horizontal position as shown in the figure. The angular velocity of the rod as it passes the vertical position is. So here the concept which we will be using is that the mass of the rod is concentrated at this point and this length is L by 2, right? So at this position it is having some potential energy. When it will come to the vertical position, L by 2 will be here. So L by 2 had come from this point to this point and this distance is nothing but L by 2. So there is a change in potential energy. If we consider this point to be the ground level, potential energy here will be 0. So initially potential energy is equals to mg into h is L by 2. This is the potential energy, right, at the height. And this potential energy is converted into angular kinetic energy, and angular kinetic energy is given by half I omega square, where I is what? I is the moment of inertia about this point O. So the moment of inertia of a rod of length L about its one of end is being given as, here I will be equals to m L square by 3. So putting ml square by 3 here in I, we can see here it will be equals to mg into L by 2 is equals to half, this is I and this is omega square. Calculating this, we get omega is equals to under root 3 g by L. Under root 3 g by L is under root 3 g by L is option 2. So the correct answer for your question number 12 is option 2, right? Correct answer is option 2. Now question number 13. The center of mass of a solid cone along the line of the center of the base of the vertex. This you have to remember. It is 1/4 of the height. So the correct answer will be option 1. Right? The center of mass is, this is the cone and this is the height h. This is the height h. So this is h by 4. And here is the center of mass located. So you have to remember it that for a cone it's h by 2, that is from the base, center of the base. Right? Now next coming to question number 14. Question number 14 says that a circular disc is to be made of using iron and aluminium so that it acquires a maximum moment of inertia about its geometrical axis. It is possible with, see, if you need to increase moment of inertia, most of the mass has to be concentrated as far as away from the axis, right? Now we know iron has a greater density as compared to aluminium. So if we place iron in the periphery, it means outside, and aluminium inside, right? Then it will have greater moment of inertia. So this arrangement has been given to us in aluminium is the interior and iron in the surrounding. Iron in interior, aluminium surrounding, using iron and aluminium layer sheet metal. So the correct option is option 1, right? So what? Because moment of inertia I is equals to mr square. So if we increase r, right, moment of inertia will increase. and also if we increase m, moment of inertia will increase. So because iron has greater density, so to keep the moment of inertia maximum for the disc, heavier metal is being placed at the outer side so that we get the maximum moment of inertia, right? So this therefore correct answer for question number 14 is option 1. Now coming to question number 15. Question number 15. The angular speed of flywheel making 120 revolutions per minute is 120 revolutions per minute. 120 revolution. Revolution means one revolution is 2 pi. So radian converted into is 2 pi. This will give you radian per minute. Per minute means for every 60 seconds, right? So this numerator is now written in radian, and this is in time is in seconds. So this will be equals to 2. So it will be 4 pi radian per second, right? So the angular speed will be equals to 4 pi radian per second. So correct answer is option 1. 4 pi radian per second, right? One revolution is equals to 2 pi radian. So 120 revolution will be equals to 120 into 2 pi. 1 minute is 60 seconds. So divided by 60 seconds, you'll get 4 pi radian per second. Now question number 16. Question number 16 says that what is the value of linear velocity if omega and r is been given to us as this. So linear velocity v vector is equals to omega vector cross r vector. So here we are finding the cross product of the omega vector and r vector. So we have used the determinant method. So we finally get it as 18 I cap plus 30 minus 13 j cap plus 2 k cap. Now let's see how we have done it. Finding the cross product, we draw the determinant. Here it's I cap, j cap, k cap. First is omega. So let's write the components of omega. Here it is 3, then minus 4, then 1. Then for r it is 5, minus 6 and plus 6, right? So for I cap, it will be equals to, leaving this column, leaving this row, it will be minus 4 into 6 is minus 24, minus 24, minus 6 into 1 is minus 6, and minus minus will become plus, which is 6, right? Minus j cap into, leaving this column and this row, 3 into 6 is 18, minus 5 into 1 is 5, right? Then plus k cap, leaving the column of k and ijk as row, multiplying this will give you minus 18, minus 5 into minus 4 is minus 20, so minus 20 and this minus will become plus 20, right? So this would result in minus 18 I cap minus 13 j cap plus 2 k cap, right? So this is the cross product of omega and r, which is nothing but v vector. So the correct answer will be equals to option 2. The correct answer for 16 is option 2. That is what we have followed over here is v is equals to omega cross r. Now next coming to question number 17. The question number 17 says that a solid cylinder of mass m and radius r rolls without slipping down an inclined plane of length L and height h. Right. What is the speed of its center of mass when the cylinder reaches its bottom? Right. So when the cylinder is coming from the top of an inclined plane to the bottom, what is happening is its potential energy at the top is converting into kinetic energy at the bottom. So using the law of conservation of energy, this is the potential energy mgh at the top of the inclined plane. Half mv square is its translatory kinetic energy, and half I omega square is its rotational kinetic energy, right? Now because this is a solid cylinder, it will have its value of I is equals to mr square by 2. I is equals to mr square by 2, and omega can be written as V by R. So your translatory kinetic energy is equals to half mv square plus half I omega square, right? Half I omega square. Solving this, we will get V is equals to under root 4 G H upon 3. Under root 4 G H upon 3 is in our option 3, right? So what we have used here is law of conservation of energy, that is M G H at the highest most point is equals to half mv square, that is translatory kinetic energy, plus half I omega square, right? That is rotational kinetic energy. I is equals to how much? Is m r square by 2, and omega is v by r. V is being given in the question, r is being given in the question. No, not given in the question. When we solve it, we finally get it as v is equals to, we need to calculate v, so we get v is equals to under root 4 gh upon r. We have to solve this equation, putting the values which I have mentioned here. I will be put as, we put I as mr square by 2 and omega as v square v upon r, right? The correct answer for question number 17 is option 3. Coming to question number 18. Question number 18 says that the angular momentum of two bodies rotating angular momentum are in the ratio, that is L1 upon L2, L1 upon L2 is equals to 1 upon 2. If the moment of inertia about these axes are in the ratio 1 upon 2, that is I1 upon I2 is also equals to 1 upon 2, ratio of the kinetic energy. So ratio of the kinetic energy is equals to your 1 by 2 L square upon I, right? This is rotational kinetic energy in terms of angular momentum and moment of inertia, right? Angular momentum and moment of inertia. From here we can say that K1 upon K2 is equals to your L1 upon L2 square into I2 upon I1, right? So this will be equals to 1 upon 4 into 2 upon 1, which is equals to 1 upon 2. So the ratio K1 upon K2 will be 1 is to 2, which is in your option 1. So correct answer is 1 is to 2, that is option 1. So the correct answer for question number 18 is what? Option 1, right? And now if the question arises how we got this, so see, you have kinetic energy K is equals to half I omega square, right? Half I omega square. Now this omega is into I upon I. This will become your K is equals to half I omega whole square upon I. And what is I omega equals to? I omega is equals to L. L is equals to I into omega, right? So we'll put it here. So we'll get K is equals to half L square upon I. This is how we got the formula, right? Now let's see question number 19. Question number 19 is a particle undergoes uniform circular motion about which the point in the plane of the circle will the angular momentum of the particle remain conserved. It's about the center. The correct answer is option number 19. How option number 1, see, if this is the circle, that is the particle over here is under circular motion, and if this is the center, then this will be the radius, and the only force experienced by this particle will be centripetal force, which will be along this radius, right? So about this center, the force is passing through the center. So if we calculate torque over here, F will be equals to your centripetal force, but R will be equals to 0. That is the distance, perpendicular distance of force from the pivot will be equals to 0. So torque will be equals to 0. Now if torque is equal to 0, then the momentum has to be conserved, right? So the angular momentum of this particle will be conserved at this point. Now coming to the second option, on the circumference of the circle. Now if the particle is moving with a circular motion, this is the particle, this is the direction of the force, and this is the point about which we have to calculate the torque, right? So this will be R, right? So definitely there will be an angle. If there is an angle, then torque will be equals to your Fr sine theta. It will contain some value. So net torque will not be equals to 0. So momentum will not be conserved. Again, inside the circle, so if we draw a circle, this is the path of the particle. This is the center. This will be the direction of centripetal force and point inside the circle. This is the point about which we need to calculate the moment of inertia. Sorry, torque. So this will be R. Again, it will have some angle. Now, if it had some angle, tau will have some value, and if tau will have some value, momentum cannot remain conserved, right? Therefore, option 3 is also wrong. Similarly, outside again you will get some value for R theta. Therefore, the torque will not be equal to 0. So out of these four options, for these three options, net torque will not be equal to 0. So if net torque is not equal to 0, angular momentum will not be conserved. For the first option, that is at the center of the circle, the value of net torque is equal to 0. Therefore, the momentum will be conserved. Right? Now coming to question number 20. It says that the moment of inertia of a flywheel I is given to us as 4 kg meter square, right? The angular acceleration will be produced in it by applying a torque tau is equals to your 10 Newton meter. They are asking you alpha, right? So we have the formula tau is equals to I alpha. I is been given to us, tau is been given to us. Directly we can use the formula to calculate the value of alpha. So alpha will be equals to tau upon I. Putting the value, we get 2.5 radian per second square. So the correct answer will be option 1, that is 2.5 radian per second square. See the right formula based question. If you remember that tau is equals to I alpha, you can easily calculate alpha. Next, coming to question number 21. 21 says that three identical rods, each of length L, are joined to form the rigid equilateral triangle. Its radius of gyration about the axis passing through the corner of a corner and perpendicular to the plane of the triangle. So according to the question, this is the arrangement of the rods. Each rod has its length L, and the moment of inertia is to be calculated about the rod which is passing through this vertex and is perpendicular to the plane. So moment of inertia for this rod will be ml square by 3, that is moment of inertia of a rod about its one end. Same will be for this, that is ml square by 3, ml square by 3, and for it will be equal to, this is m and this is the distance, right? Now if this is the distance, this distance will be equal to root 3 by 2, right? This distance will be root 3 by 2. By simple trigonometry, we can calculate this is 60 degrees, right? This is 60 degrees. This is L by 2, right? So, and this will be equal to how much? This is L. If this is L, this is 60 degree. This will be equal to L sine 60, which is equals to L root 3 by 2. So, moment of inertia of this rod will be equals to m into root 3 L by 2 ka whole square, which is equals to 3 m L square upon 2, right? So net moment of inertia will be equals to ml square by 3 plus ml square by 3 plus 3 ml square by 2, right? So 2 ml square by 3 plus 3 ml square by 4. Yeah, it's ml square by 4 na square ho jayega. Ml square by 4, right? So this ml square by 4, adding all these three, that is ml square by 3 plus ml square by 3 plus 3 ml square by 4, ml square by 4 will give you net moment of inertia as 3 by 2 ml square, right? Net moment of inertia is 3 by 2 ml square. Total mass is equals to 3m. So 3m into k square is equals to 3 by 2 ml square. So from here we get the value of k as L by root 2. We get k is equals to L by root 2. So the correct answer for this question number 21 is option 3, right? Net moment of inertia we got 3 by 2 ml square. Total mass of the 3 rod is equals to 3m into radius of gyration k ka whole square. So 3m and 3m cancels out. We get k square is equals to L square upon 2. So we get k is equals to L upon under root 2. K is equals to L upon root 2. So the correct answer is option number 3. Now next coming to question number 22. Question number 22 says that a ring, a solid sphere and a thin disc of different masses rotate with the same kinetic energy. Equal torque are applied to stop them, which will make the less number of rotations before coming to rest, right? C, number of rotations. Work done is equals to force into displacement, so we can write it as tau into theta, right? And work done is nothing but energy, right? So from here we can say that theta is equals to E upon tau. Now for all the three shapes, E and tau are same. So if E and tau are same, theta will also be same. So for all the three, theta is same. So the correct answer will all will make same number. Option 4. Option 4, that is all will make the same number of rotation. Why? Because theta is equals to E upon tau and E and tau is same for both the all the three bodies. So all the three bodies will make same number of rotations. Now coming to question number 23. Question number 23 says that a disc of mass 2 kg and radius 0.2 meter is rotating with an angular speed of 30 radian per second. If a mass of 0.25 kg is put on periphery of the disk, then the angular velocity of the disk is, right? So initially the disk has a mass of 2 kg and radius is equals to 0.2 meter. So for this, if we calculate the moment of inertia, for the disk we have moment of inertia is equals to mr square by 2. Now putting the values, we get moment of inertia 0.04 kg meter square, right? So the angular velocity from here you will get is equals to 30 radian per second, which is being given in the question, right? With this moment of inertia, omega is 30 radian per second. That is I1 is equals to 0.04 kg meter square and omega 1 is equals to your 30 radian per second, right? Now what is happening? We are placing a mass of 0.2 kgs at the periphery, that is at the outermost position of the disk. So now the moment of inertia changes as 2 into m r square plus m into r square. M means the small mass 0.25 kg placed on the periphery. So now the new moment of inertia is 0.05 kg. So we can write it as I2 is equals to 0.05 kg meter square. They are asking us to calculate omega 2. So we can see that there is no external torque acting on the body, so the momentum will remain conserved. So angular momentum is I 1 omega 1 is equals to I2 omega 2. We have I1 and omega 1, we have I2, need to calculate omega 2, putting the values, finally we get omega 2 is equals to 24 radian per second. So the correct answer for question number 25, the 23, question number 23 is your 24 radian per second, that is option 1, right? So we first calculate moment of inertia for the disk and the angular velocity was being given to us. Then we calculated the moment of inertia for the disk plus additional external mass, and then we need to calculate the angular velocity for that case. So using the concept of conservation of angular momentum, because the net torque acting on the body is equals to 0, that is I1 omega 1 is equals to I2 omega 2. Putting the value of I1 omega 1 and I2, we get omega 2 as 24 radian per second. Now question number 24. Question number 24 says the moment of inertia of the two freely rotating body A and B are IA and IB, where IA is greater than IB, and their angular momentum are equal. Angular momentum are equal. That is L of A is equals to L of B. L of A is IA into omega A is equals to I B into omega B. Now the kinetic energy K and KB are their kinetic energies, then they are asking about their kinetic energies. Okay. So kinetic energy K, we will be using the formula which I have already discussed here, this L square upon I, right? So moment of energy, so angular momentum for all the bodies are same. It means here the kinetic energy is inversely proportional to moment of inertia. So if I A is greater than I B, then your K A will be less than KB. So Ka less than Kb is in option 3. So the correct answer is option 3. From this formula, the basic formula which we will be using here is your K is equals to 1 by 2 L square upon I. From here we get kinetic energy is inversely proportional to moment of inertia, and because the moment of inertia of A is greater, so its kinetic energy will be lesser. So the correct answer is option 3, that is kinetic energy of A will be less than kinetic energy of B. Right, now let's coming to question number 25. Question number 25 says that a thin rod shown below has mass m and length L. A force F acts on one end as shown in the figure. The rod is free to rotate about the other end in a horizontal plane. The initial angular acceleration of the rod, angular acceleration. So the force is acting in this direction. Angle here is 30 degree, right? So vertical component of the force will be equals to F sine 30, right? F sine 30. And the perpendicular distance of this force from the fixed point pivot will be equals to L. So torque is equals to F sine 30 into L, and torque is also equals to I into alpha. For moment of inertia for a rod fixed at its one end, I will be equals to m L square by 3, ml square by 3, right? Yes. So we have C tau is equals to I alpha, and tau is also equals to F sine theta into L. Equating both the values, that is F sine 30 L upon ml square upon 3, we get alpha is equals to 3F upon 2ml. So the correct answer is your option 1, right? Because this torque is by the concept of moment of force, and this is by the concept of angular rotation, that is I alpha. Both the torques are same, so we can equate them and find the value of alpha, right? Now next, coming to question number 26. Yes. Question number 26 says that a circular plate of uniform thickness has the diameter of 56 centimeters. Diameter 56, it means radius is equal to 28, right? The circular portion of diameter 42, 42 is the diameter, so radius will be 21 centimeters, is removed from one edge as shown in the figure. The center of mass of the remaining portion from the center of the plate will be. So this could be easily understood from this diagram. See, this is the whole disc. Out of this disc, this portion is being cut out. So what we are left with is this, right? So if we see, the center of mass for the original disc is at 28 centimeter here, and center of mass for the disc which we are cutting out is at 21 centimeter. You can say it's here, right? It is here, right? So now we have to calculate center of mass. So here the mass is being separated out. So we have the formula na, x component of center of mass is equals to m1 r1 or x1 m1 x1 plus m2 x2 upon m1 plus m2. This is when the mass of all the particles or all the masses to be taken. But here the mass has been removed. So what will happen? This plus sign will change into minus sign. So we will get x component of center of mass is equals to m1 x1 minus m2 x2 upon m1 plus m2, right? m1 plus m1 minus m2, sorry, it will be m1 minus m2. So if we look into the calculations over here, mass of the disk is not being given because it's a uniform disk. So mass per unit volume is density. So density here, this mass can be written as volume into rho. Here also volume into rho, and here in this volume into rho. Here also volume into rho. This is equals to V1. This is V2. This is again V2, and this is V1. But rho will be same. So rho can get cancels out, right? Again in the volume, the thickness is same. Volume can be written as area into thickness. Thickness of the disk is same, so thickness also gets cancelled out. So we can simply write area of the first disk into x1 minus area of the second disk into x2 upon area of the first minus area of second, right? Putting the values, area of the first disk is equals to pi r square, r was 28, minus the into x1 is minus 28, right? We can see we have original here, and then the x component is in the minus x, so it will be minus 28. Then minus this is a2 into x2 upon a1 minus a2, right? For a2 the radius is 21. Putting these values and calculating, we get x of center of mass is equals to minus 37. So on the coordinate axis, the center of mass is lying at 37, right? At 37. Original disk had its center of mass at 28. So the distance between the two is 9 centimeters. So they are asking that the center of mass of the remaining portion from the center of the plate. So from the center of the plate, it is at 9 centimeters. So the correct answer will be your option C, right? That is from the center of the original plate, the new center of mass is at 9 centimeters, right? So the correct answer is option C. Now next, coming to question number 27. Question number 27 says that a sphere rolling on a smooth surface collides elastically with a wall as shown. The angular momentum of the sphere will remain constant. Again, the same question. When it's collide with it, the force, the impulse acting, the change in velocity or the impulse acting will be along the radius and will pass through the center, right? So if it is passed through the center, the direction of the force and the fixed point r will be equals to 0. So tau net will be equals to 0. So momentum will remain conserved about its center. So what the options they are given is the point of the contact between the sphere and the ground, no, because the centripetal force will be acting in this direction and there will be a perpendicular distance. So torque will not be equals to 0 here. Any point on the wall, no. Any point on the sphere, no. A line passing to the center of the sphere and perpendicular to the wall, yes. A line passing the center and perpendicular to the wall. So this is perpendicular to the wall and this will pass to the center. So for this, the torque will remain, torque will be equal to 0, and because torque is 0, the angular momentum of the sphere will remain conserved. So the correct answer for question number 27 will be option 4, right? Now coming to question number 28. Question number 28 says that a body of mass 10 kg is moving with a uniform speed of 6 meter per second in an xy plane along the line this. The magnitude of its angular momentum about the origin is. Alright. So if we see, this is y is equals to 4 by 3x plus 10 by 3. Right? If this is the equation, we get from here tan theta, that is slope, is equals to 4 by 3, right? And y-intercept is equals to 10 by 3. So if you look into this graph, the direction of linear momentum, right? This is the direction of MV, and R is this. This is R, right? Or you can say that if this is MV, this will be equals to your MV cos theta. MV cos theta. And the perpendicular distance will be equals to this, which is being given as y-intercept, and y-intercept is equals to 10 by 3. So putting the values, we get m is equals to 10 kg into v is 6 into cos theta. Theta over here is tan theta is 4 by 3. So your cos theta will be equals to 3 by 5, right? Cos theta will be equals to 3 by 5. So cos theta is equals to 3 by 5 into perpendicular distance. The perpendicular distance is 10 by 3. So this 3 and this 3 cancels out, 5 and 2, so 20 is equals to 120, right? So 120 kg meter per, kg meter square per second. So the correct answer for this question is option 2, that is 120 is the correct answer, right? I hope this is clear. Again, you can see this is the case. This was the direction of linear momentum because this was the direction of the velocity, and this angle is equals to, we can calculate, is equals to tan theta is equals to 4 by 3. So from here, this linear momentum can be resolved into its horizontal component, and this will be equals to mv cos theta, right? And the distance is the y-intercept. R will be equals to y-intercept, that is equals to 10 by 3. So using the formula, that is linear angular momentum, L is equals to mv cos theta into R. Putting the values, we get our angular momentum as 120 kg meter square per second. That is option 2. Next, coming to question number 29. A uniform wire of length 2L is bent to form an angle of 90 degree as shown. Find the distance of the center of mass. Okay, so this could be understood like this. Suppose this is the coordinate system, and let the vertex of the two rods be equals to like this. The rods be placed like this. This length is L, this length is L, so its center of mass would lie here at L by 2, and it's also here L by 2. So the center of mass of this system would lie at the center of this line joining the two masses, right? Center of this line joining the two masses. So if this is L by 2 and this is L by 2 and this angle is 90 degree, so this will be 45 degree and this will be equals to 45 degree. What we need to calculate is this length and then divided by 2. So if we have a triangle like this, this, this is L by 2, this is L by 2. So we need to calculate this, right? So it will be equals to root 2 times of L using the Pythagoras theorem. Yes, under root of L by 4, L square by 4 plus L square by 4. So it will be equals to 2 times of L square by 4. So under root of this, so it will be equals to under root 2 into L square by 2. So this will be equals to L, L square by 2 means L by 2. So L by root 2, right? So this length will be equals to L by root 2 and center of mass will be at center of this. So this position will be L square by root 2 divided by 2. So center of mass will be at L by 2 root 2. So the correct answer is option 3. Correct answer is option 3. Right? I would explain it again with the diagram. See like this. Yes. So if this is the coordinate system, x-axis, this is the rod, this is the rod, mass is at this point, length, if length of the rod is L, this will be equals to L by 2. Again here, the mass at the center of the rod, so this length will be equals to L by 2. And this angle has been given to us as 90 degree. So using Pythagoras theorem, we get this line equals to, length of this line is L by root 2, right? And center of mass will be lying at the center here. That is half of the length of this line. Half of the length of this line is L by root 2 ka half. Will give you L upon 2 root 2, right? So this is L upon 2 root 2. So the correct answer is L upon 2 root 2. Or if you want to understand this solution, again see R1. R1 is equals to L by 2 cos 45 I cap plus sin 45 J cap. That is, this L by 2 is being resolved into its vertical component. This will be equals to L 45 sin 45, L by 2 sin 45, and this will be L by 2 cos 45. Similarly, this will be resolved as L by 2 sin 45 and L by 2 cos 45. L by 2 sin 45, L by 2 sin 45 get cancelled out because they are in opposite direction. What we are left with is L by 2 into 2 into cos 45. Cos 45 is 1 by root 2. So this will be equals to 2 into L by 2 into your 1 by root 2. Right? So wait a minute. L by 2 cos 45 plus L by 2 cos 45. Alright. Let it be. You just understand by this diagram, right? So the answer will be equals to L by 2 root 2. So now let's coming to question number 30. Question number 30 says that an automobile engine develops a power of 100 kilowatt power when rotating with an angular speed of 250 radian per second. So they have given to us as power is equals to 100 into 10 to the power of 3 watt, and omega is equals to 250 radian per second. They are asking you torque developed. So P is equals to tau into omega. In this formula, put the value, you will get the answer. So that is equals to 10 to the power of 5 upon 250 will give you 400 Newton meter. 400 Newton meter is your answer. That is question number 30 has a correct answer as option number 4, that is 400 Newton meter using the formula P is equals to tau into omega. Right. Now let's come to question number 31. Question number 31, it says a rigid body rotates about a fixed axis with variable angular speed. Is given to us as this, that is omega is equals to omega is equals to 3 minus 5t at any time t, the angle through which it rotates before it comes to rest. So omega is being given to us as 3 minus 5t. Now when the object comes to at rest, omega becomes equals to 0. So at omega is equals to 0, we get t is equals to 3 by 5 seconds, right? 3 by 5 seconds. They are asking you the angle, right? Angle is omega is equals to d theta by dt. So we can write it as omega dt is equal to d theta. Integrating this with respect to time from 0 to 3 by 5. From 0 to 3 by 5. So what we are integrating is, we are integrating your d theta from 0 to theta is equals to integral 3 minus 5t dt from 0 to 3 by 5. Integrating this and solving, we will get your theta is equals to 9 by 10, right? Integrating this and solving, get theta is equals to 9 by 10. So question number 31 has a correct answer as option 1, which is 9 by 10, right? So the formula which we have used over here is, that is omega is equals to d theta by dt, right? Now next, coming to question number 32. Question number 32 says that a disc of radius 2 meter and mass 100 kg roll on a horizontal floor. Its center of mass has a speed of 20 centimeter per second. 20 centimeter per second. How much work is needed to stop it? Work needed will be equals to the energy possessed by the body, right? So because the body is rolling, it will have both kinetic energy, translator kinetic energy, and rotational kinetic energy. So in the question, the mass is been given to us as 100 kilograms. Velocity is given as 20 centimeter per second. 20 meter per second is equals to your 0.2 meter per second, right? Radius is equals to 2 meters, and according to the work energy theorem, work done to stop the disc is rotational kinetic energy plus translator kinetic energy. So rotational kinetic energy equals to half I omega square. For a disk, I is equals to half mr square, and omega is equals to v by r, right? So the rotational kinetic energy will come as 1 joule. Putting the values, we get half into m is 100 into r square. R square will be equals to 4. So this is equals to this is half I into omega square. Omega is v by r. So v is equals to 0.2 into 0.2 upon 4, right? So this 4 and 4 gets cancels out. Then this and this cancels out at 100. This 2 and this 2 gets cancelled out. We get 2 joule, right? So we get it as 2 joule. Let me check it again. Half I is m is 100, r square, mr square is 4, right? This is half I. Omega is v by r. So V is your 20. So it's 2 meter per second square. So 0.2. 0.2 into 0.2 omega square. V square upon R square. R square is equals to 4. So this 4 and this 4 cancels out. 100 से ये decimal place हट गया. Now this 2 and this 2 we get 2 joule. So the rotational kinetic energy will be equals to 2 joule, right? And translatory kinetic energy is equals to half mv square. So half into m into v square. V square is 0.2 into 0.2. So this is equals to how much? Is this decimal place goes off with 100. This 2 and this 2 cancels out. We get 2. So this is also equals to 2. So 2 is the rotational kinetic energy and 2 is the what? Translatory kinetic energy. So the total energy will be equals to 4 joule. Total energy will be equals to 4 joule. But we don't have this in our option. That is our 3 joule only. Let me cross check it. Half I omega square. Half I I M. Okay, right, got it. I'm missing 2 over here, right? Half I omega square into half. So this half will make it as 1. This will make it as 1. So the answer will be 3 joule, right? Correct answer will be 3 joule. So the correct answer is option 1, that is 3 joule, right? I solve it here again. That is your rotational kinetic energy will be equals to half into I is half into 100. This is m. R square is equals to 4, right? This is mr square. This is moment of inertia I into omega square. Half I omega square. Now omega square will be equals to 0.2 into 0.2 upon 4, right? Solving this, you will get 1 joule. 1 joule. So rotational kinetic energy is equals to 1 joule and translatory kinetic energy is equals to 2 joules. So total energy is equals to 3 joules. So the correct answer for question number 32 is option 1, that is equals to 3 joule, right? Now let's come to question number 33. Question number 33 says that a shell following a parabolic path explodes somewhere in its flight. The center of mass fragment will move in parabolic path. That is the vertical any direction, horizontal direction, same parabolic path. Option D. Why? Because there is no external force acting on the shell, and if no external force is acting on the shell, the momentum is conserved, and if the momentum is conserved, the center of mass will follow the same path as it was following initially, right? So the correct answer is option D, because the particle is following a parabolic path, so the center of mass even after the explosion will follow the same parabolic path, right? Next, coming to question number 34. Question number 34 says that a rigid body rotates with a constant angular acceleration. Angular acceleration alpha is being given to us as 4 radian per second square. Now, if it starts from rest, then the number of revolution it makes in the first 8 seconds. Starts from rest, that means omega naught is equals to 0, right? Omega naught is equals to 0. The number of revolution it makes. Alright. So number of revolutions can be calculated if we calculate theta. We will use the formula theta is equals to omega naught into t plus half alpha t square, right? This will become 0 because omega naught is 0. So your theta will be equals to half into alpha. Alpha is been given to us as 4 into t square has been given to us 64, right? So this is equals to t. So theta is equals to 128 radian, right? 128 radian. One revolution is 2 pi. So divided by 2 pi, it will give you approximately equals to 20 revolutions. So the correct answer is option 2, right? This is the angle. When you divide it by 2 pi, you will get number of revolutions. So number of revolutions will come approximately equals to 20 revolutions. So the correct answer is option number 2. Now coming to question number 35. Question number 35 says that the rod of the length L leans against the smooth vertical wall while its other end is on a smooth floor. The end that leans against the wall moves uniformly vertically downwards. Select the correct alternative. See, if this is the case, if it is moving vertically downwards, if the velocity in this direction is Vy and the velocity of this rod in this direction is Vx, and if we see for, let's say, time t, for time t, this distance will be moved for 1 second. Let's calculate it for 1 second. So the distance moved the by this end in 1 second will be equals to Vy, and distance moved by this end will be equals to Vx. So this is Vy, this is Vx, and at that instant this is equals to theta. Now as this moves forward and this moves downward, this theta changes, right? This theta changes. So if we calculate theta, we will get tan theta is equals to Vx, sorry, Vy upon Vx, Vy upon Vx, right? So when the rod is horizontal, theta is equals to 0 degree. Now when theta is equals to 0 degree, it means tan theta is 0. It means Vy upon Vx is equals to 0. It means finally Vy becomes 0. So out of this logic, if we see that the speed of the lower end increases at constant rate, no, it does not increase. The speed of the lower end decreases but never becomes 0. No, the speed of the lower end gets smaller and smaller and vanishes when the upper end touches the ground. Yes, it vanishes because see, it's finally resulting into 0, right? The speed of the lower end remains constant till the upper end touches the ground. So according to this, you can say the correct answer is option 3, right? Correct answer is option 3. Why? Because this will move forward until this is moving downwards, and finally when the rod touches the ground and becomes horizontal, its velocity will be 0. So it has been said in your option 3. So the correct answer will be option 3, right? Next option, question number 36. Question number 36 says that a force is equals to 2 I cap plus 3 k cap acts on 1, 0, 0, then the torque about this. So this is the point 0, 4, 0, and the mean force is being act on this point, right? So this is F vector and this will be your R vector. So R vector is equals to final position minus initial position. So your R vector will be equals to final minus initial, that is 1 minus 0 I cap plus, for J it is 0 minus 4 J cap plus 0 minus 0 K cap. So we get R vector as I cap minus 4 J cap. That's it, right? So we have F vector as 2 I cap plus 3 K cap and R vector as I cap minus 4 J cap, and tau is being given to us as tau vector is R vector cross your F vector. So finding the cross product, here we are finding the cross product, right? Finding the cross product, we get the cross product as minus 12 I cap minus 3 J cap plus 8 K cap, right? So the correct answer for question number 36 is minus 12 I cap, which is in option number 1, right? So this is how we'll find the R vector from here. F vector has been given to us, and finding the cross product of F vector and R vector, that is the tau vector is equals to r vector cross f vector. Finding the cross product, we get our answer as minus 12 I cap plus 3 minus 3j cap plus 8 k cap, right? Now coming to question number 37. A particle starts with an angular acceleration of 2 radian per second square. Alright, alpha has been given to us. On a circle, it moves 100 radians in a random interval of 5 seconds. Alright, find out the time at which the random interval starts. Okay, so at random interval, the angle moved is your 100 radian. So see, if the object is starting from rest, that is omega 1 is equals to 0. So theta 2 for T2, in T2 it moves the distance of theta 2 using the formula that theta is equals to omega naught into T plus half alpha T square. We are getting theta 2 as this, and similarly theta 1 as this, putting T2 and T1 for theta 2 and theta 1 respectively. Now theta 2 is a full angular displacement, theta 1 is the initial angular displacement, theta 1 is the time t and theta 2 is the final time. Now finding a difference between theta 2 and theta 1, we will get theta 2 minus theta 1 is equals to T2 square minus T1 square, which is equal to T2 minus T1 into T2 plus T1. And theta 2 minus theta 1 has been given to us as 100 radian. So putting the value here as 100 is equal to T2 minus T1 into T2 plus T1, right? Now, according to the question, they are saying that time interval is of 5 seconds. It means that T2 minus T1 can be put as 5. So putting T2 minus T1 as 5, we will get your T1 plus T2 as 20 seconds, right? So what we have T1 plus T2 is equals to 20, and we have T2 minus T1 is equals to 5, right? Solving this, we will get 2 times of T2 is equals to 25, right? So T2 is equals to 12.5 seconds. So your T1 will be equals to 7.5 seconds, right? So this is the starting time. We are asking you the starting time, interval starts. So interval start at 7.5 seconds. So the correct answer is option 1, right? Again, we found the angular displacement theta 1 and theta 2, and the difference between theta 1 and theta 2 is your 100 radians, right? And difference of theta 1 and theta 2 is coming as T2 square minus T1 square. Putting the values, we get here T1 as 7.5 seconds. Now next, coming to question number 38. A disk of mass m and radius r is rolling with an angular speed of horizontal plane as shown in the figure. The magnitude of angular momentum of the disk about its origin, right? So see, this is a question of pure rolling. So when it is rolling, it will possess two angular momentum, that is translatory angular momentum and rotational angular momentum, right? So in case of a pure rolling, V is equals to R into omega, where V is the velocity of center of mass, omega is the velocity of the disk, right? Now the angular momentum about the origin will include the angular momentum due to the translation as well as angular momentum due to rotation, right? That is L about origin is equals to LT plus LR. Now, so LT, that is translatory rotational motion, is M into V into R, M into V into R, plus your rotational angular momentum is I into omega, right? So I of center of mass for the disk is equals to mr square by 2, and V of center of mass is omega r. Putting these values here, putting these values here, we get angular momentum about origin is equals to mr omega. Putting V as r omega, mr omega into r plus mr square upon 2, this is I and this is omega, right? Again, from here what we get, solving this, we will get L naught, that is linear momentum, angular momentum about origin is equals to 3 by 2 mr square. 3 by 2 mr square. So the correct answer for this question is 3 by 2 mr square, which is option 3, right? Which is option 3. Now coming to question number 39. Question number 39 says that the two thin discs each of mass m and radius r are attached to form a rigid body. The moment of inertia of the system about its axis passing through the diameter of the disc and in the plane of the disc is shown in the as shown in the figure. So moment of inertia of a disc with its axis along its diameter and passing through the and in the plane of the disc is I is equals to your mr square by 4, right? So for this moment of inertia, if I write it as IAA, it will be equals to mr square by 4. For disc B, using parallel axis theorem, IBB will be equals to its mr square by 4, that is moment of inertia about its diameter, plus the parallel distance between the axis of rotation. This distance is equals to r plus r, that is 2r. So it will be equals to plus m into 2r square, which is equals to, we will write it as mr square upon 4 plus 4mr square, right? So the total moment of inertia of the system will be equals to mr square by 4 for the disc A plus mr square by 4 plus 4mr square for the second disc. Adding all the three terms, we get total moment of inertia is equals to 9 by 2 mr square. So the correct answer is your option 3, that is 9 by 2 mr square. For the first disc, it will be mr square by 4. Second disc, it will be equals to mr square by 4 plus 4 mr square. Adding all the three, we'll get the total moment of inertia as 9 by 2 mr square. Now coming to question number 40. Question number 40 says, in the figure given below, a child of mass 4 kg is standing on the wooden plank of mass 40 kg, which is kept at rest with the horizontal smooth ground. Alright. If the child walks on a plane with a velocity of 10 meter per second with respect to the plank, then the velocity of the plank with respect to the ground will be. Now if let the velocity of the plank with respect to ground will be, it will be in this direction, it will be equals to v, right? Then the velocity of child with respect to the ground will be equals to 10 minus v, right? Initially it is at rest, so and there is no external force acting on the body, so the momentum will remain conserved. So this 0 is equals to mass of the child, that is 4 into 10 minus v, plus mass of the plank, which is equals to 40, into velocity of the plank, which is equals to minus v. So from here we get your 4 into 10 minus v minus 40v is equals to 0, or you can say that is 40 minus 4v is equals to 40v, and from here we get 40 is equals to 44v. So v is equals to your 10 upon 11. We have it? Yes, we have it. So the correct answer is option 2, that is 10 upon 11 meter per second. Now let's come to question number 41. Question number 41 says that a particle of mass 1 kg is moving along the line this, that is y is equals to x plus 3, y is equals to x plus 3 with a speed of 3 meters per second. The magnitude of the angular momentum. So this is the case. This angle is 45, y angle is 45, because from here we can say that y is equals to x plus 3, we have slope m is equals to 1, it means theta is equals to 45 degrees, right? Theta is equals to 45 degrees. And the momentum along this line is how much? Mass is 1 and speed is 3. So 3 Newton second is the momentum along this. So momentum along this will be equals to 3 cos 45. So 3 cos 45, cos 45 is 1 by root 2. It will be equals to 3 by root 2 Newton second. So momentum is in this direction, and this distance is the y-intercept. From the equation, we can see that the y-intercept is equals to 3. The y-intercept is equals to 3. So r is equals to 3. So L is equals to mv cos theta into r. So this is equals to 3 upon root 2 into 3, which is equals to 9 upon root 2. So the correct answer for question number 41 is 9 by root 2. Option 4. Option 4 is the correct answer. Right? Now next, coming to question number 42. Question number 42. See, in this, what is being done is the momentum is being resolved into its horizontal component and its vertical component. This vertical component has its distance with the origin as 0. So no angular momentum because of this component. There is only angular momentum because of this horizontal component, because this horizontal component is having a distance of 3 units from the origin. Right? This line has a distance of 3 units from the origin. Therefore, it will contribute in your angular momentum. Therefore, this component into this will give you the angular momentum. This component is 3 by root 2 and this distance is 3. So, it will become 9 root 2. Question number 42. 42 says that the 4 particles each of mass m are arranged in the corners of a square of massless square of side A. The moment of inertia of the system about an axis which is perpendicular to the plane of the square and passes through the one of the corner. So moment of inertia, suppose we have to find about this. So for this mass, the moment of inertia will be 0. For this mass, moment of inertia will be equals to ma square. For this, it will be again is equals to ma square. For yes, ma square. Now this, for this mass, this distance is equals to a root 2. This distance is equals to a root 2. So the moment of inertia for this will be equals to m into 2a square. M into 2a square. Yes. So total will be equals to ma square plus 2ma square. It will result in 4ma square. Do we have it in option? We have this in option 2. So the correct answer is 4ma square. Right? Simple. Next question number 43. Question 43 says that the two loops P and Q are made up of a uniform wire. The radius of P and Q are R1 and R2 respectively, and their moment of inertia about axis normally through the center is I1 and I2 respectively, where I2 upon I1 is equals to 4. Find R2 upon R1. See, if P and Q are made up of same wire and of same uniform wire, then their mass will be equals to, let's say, rho, which is mass per unit length, into length is 2 pi r. So mass of P will be equals to rho into 2 pi rp, and mass of Q will be equals to rho into 2 pi rq. Right? Now moment of inertia I1 is for P. So I1 will be equals to mr square. So for m we will place as rho 2 pi r 1. Let's say it r or rp, right? Rp into rp square. This is mr square, right? Similarly, I2 will be equals to rho into 2 pi rq into rq square. So dividing these, what we get, this cancels out. We get I1 upon I2 is equals to R P cube upon R Q cube. Now writing this according to the question, we will get I2 upon I1 is equals to R2 upon R1 ka whole cube. This quantity is being given to us as 4, so we'll write it as 4 is equals to R2 upon R1 raised to the power of 3. They are asking us find R2 upon R1. So R2 upon R1 will be equals to 4 raised to the power of 1 by 3. So 4 raised to the power of 1 by 3 is an option 2. So the correct answer for this question number 43 is option 2. Right. Next, coming to question number 44. The question 44 says that the ABC is a triangular plate of uniform thickness. The sides are of the ratio shown in the figure. IAB, IBC, ICA are the moment of inertia of the plates about AB, BC and CA respectively. Which one of the following relation is correct? So they are asking you to compare the three moment of inertia. See, if we find, let's start with IAB. IAB for this is IAB. This is for IAB. The R will be equals to 3. So R for AB will be equals to 3. Alright. Now if we see for BC, R will be equals to 4. So for BC, RBC will be equals to 4. For AC, this is AC. So R will be the perpendicular distance, this perpendicular distance, right? Now this perpendicular distance, if you can see, for this right angle triangle, this side is the hypotenuse, right? And this side is equals to 3. So definitely this distance will be less than 3. So R for AC is less than 3. Now if R for AC is less than 3, it means we have minimum R for AC. So if the formula of moment of inertia is I is equals to M R square. So for whichever side R is minimum, the moment of inertia will be minimum. So we can say that I of AC is less than I of AB is less than I of BC, right? So according to this, no, this cannot happen, right? Because this is less, and they are saying that this is sum of these two. So if this is least, this cannot be the sum of the other two moments of inertia. This is not maximum, this is the minimum. IAB is greater than IBC. IAB is greater, no, it is smaller than. Then IBC is greater than IAB. IBC is greater than IAB. Yes, this is correct. So the correct answer is option 4. Right? Now let's come to question number 45. Question number 45 says that a uniform solid hemisphere of radius r is joined to a uniform solid right circular cone of base radius r and height root 3r. If both have same density, then find the position of center of mass from the center of the sphere. So to find the center of mass, what we do, we place this solid such that the axis lies on the y-axis and this lies on the x-axis and this center O lies at the origin. When this is the case, the center of mass of a cone is at a distance h by 4 from its base. So here h is being given to us as root 3r upon 4. So this will be the distance of center of mass from the origin. So along the minus y-axis. So here we have drawn it as this is center of mass of the cone, that is at a distance of root 3 r upon 4 on the negative y-axis. Then for a hemisphere, the center of mass is at a distance of 3r by 8, where r is the radius of the hemisphere. So center of the hemisphere will lie at this point, that is 3 by r by 8. So now what we can assume is that there is a mass placed at this point and another mass is placed at this point, and these are the coordinates, that is this coordinate is 0 comma 3r upon 8 and this coordinate is root 3r upon 4, 0 comma. So we can see that the x coordinates are 0, so center of mass will definitely lie on the y-axis itself, right? So to find the center of mass, m1 into y1 plus m2 into y2 upon m1 plus m2. Now both the bodies are made up of same material, so they have the density same. So m1 will be equals to, m1 is for, if we take it as for your hemisphere, it will be equals to 2 by 3 pi r square h into rho, right? Sorry, pi r square, pi r cube into rho, where m2, if it is for cone, it will be equals to 1 by 3 pi r square into h into rho, right? Now putting the values of r and h, what we get the m1 and m2, and from here if you see, from here rho will come as common and from numerator also rho will come as common. So rho and rho gets cancelled out. What we are left with is the volume and volume. So here if you can see, volume of the hemisphere into its coordinate plus volume of its hemisphere into its coordinate, right? So here it will be minus sign because the coordinate for the cone is negative. So here the sign will come as minus upon the sum of the volume of the two bodies, right? Solving this, we get our answer as 0. That is, the center of mass will be at 0 position on the y-axis. That is, the center of mass will be at the origin, right? So the correct answer for this question number 45 is option 4, right? I'm writing here what we will be writing is volume of the hemisphere, that is 2 by 3 pi r cube, this is the volume, into its coordinates. Coordinate is 3r by 8, 3r by 8 plus volume of the cone is 1 by 3 pi r square into h is root 3 r, right? This is the volume into your coordinate. Coordinate is minus 3 under root 3 r by 4, right? So this is v1 into y1 plus v2 into y2 upon v1 plus v2. v1 is your this and v2 is your this. When you solve this, now you will get your numerator as 0. After solving this, you will get numerator as 0 because we have a minus sign over here. So it will subtract and finally we get this quantity as 0. So the numerator is 0. The position of center of mass will be at the origin, that is O. Right? So the correct answer is option 4. Now coming to question number 46. The angular position of a particle revolving about an axis is given by theta is equals to t square minus 3t plus 4 radian. Now find the acceleration to the point at t is equals to 2 seconds. The radius of the circle is 1 meter. So if theta is being given to like this, then omega, then omega is equals to d theta by dt. So this will be equals to 2t minus 3, right? 2t minus 3. So alpha is equals to d omega by dt. So this will be equals to 2. So alpha is equals to 2. So a along the tangent is equals to alpha into r. Alpha is 2, r is 1, so it will be equals to 2. Acceleration due to centripetal is equals to omega square r, right? So let me calculate it here. We have your a along radius is equals to omega square. Omega square is equals to 4t square plus 9, or we can do it like this. At t is equals to 2, na? So at t is equals to 2, omega is equals to 4 minus 3 is 1. 1 into omega square r is 1. So we'll get 1. So acceleration is equals to under root of at square plus ar square. So we'll get acceleration is equals to under root of 4 plus 1, which is equals to root 5, right? So the correct answer for question number 46 is root 5 meter per second square. So the correct answer is option number 4, right? Again, differentiating theta will get omega, and differentiating omega will get alpha, which is equals to 2. Tangential acceleration is alpha into r. Alpha is 2, r is 1, so we'll get 2 as at, and radial acceleration is omega square into r. So at t is equals to 2 seconds, they are asking. Putting t is equals to 2 in omega, we get omega is equals to 1 radian per second for t is equals to 2 seconds, right? So radial acceleration is equals to omega square into r. So omega square is 1 and r is 1. So we get your what? Radial acceleration as 1. To find acceleration experienced by the body, it will be equals to resultant of both the radial and tangential acceleration. So resultant will come as root 5. The correct answer for this question is option 4, that is root 5 meter per second square. Coming to question number 47. Question 47 says that two cylinders P and Q of same mass and same radius, alright, rolling down a plane inclined fixed inclined plane from the same height at the same time. Cylinder P has most of its mass concentrated near its surface, while Q has most of its mass concentrated near its axis. Choose the correct statement regarding the motion of P and Q. Both P and Q reach the ground at the same time. Both P and Q reaches the ground with the same translatory kinetic energy. Both P reaches the ground with larger angular speed. P reaches the ground with a larger angular, Q reaches the ground with a larger angular speed. See, if we talk about the angular speed first, angular speed is omega, right? Now, if both the bodies, the kinetic energy for both the bodies will be same, because both the bodies are being released from the same height, right? Because they are released from the same height, the potential energy possessed by both the bodies at the same height, because they have the same mass and same radius, will be same. That is, potential energy at that point will be same. So the kinetic energy at the bottommost position will be same, and kinetic energy is equals to half L square upon I. Now, if kinetic energy is same for both the bodies and I for P, now because P has most of its mass at its circumference, so I for P will be greater than I for Q, right? Now, if this is the case, then we can say that L square is proportional to K into I. L square is equals to K into I, where K is constant for both the bodies So L is directly proportional to I, or from you can say that L is equals to I omega, right? So from here we can say angular momentum for P will be greater than angular momentum for Q, and I P into omega P is greater than I Q into omega Q, right? So from here you can say that I P upon I Q is greater than omega Q upon omega P, right? So, or you can place it at 0. So what we conclude from here is that the angular speed for Q will be larger, right? For Q will be larger. Why? Because this I is small, this Q will be, when I is small, omega will be more. Omega will be more. So what they have written over here is, again you can see here that IP is greater than IQ, and acceleration is being given by the formula A of P, acceleration of P is equals to G sin theta upon IP into 1 plus mr square. Similarly, acceleration of Q is being given here. So from here what we see that acceleration is inversely proportional to moment of inertia. Now acceleration is inversely proportional to moment of inertia. So acceleration of P will be less than acceleration of Q, because because moment of inertia of P was greater, so acceleration will be smaller. Now if acceleration is small, so velocity will also be small. So by this we can say the kinetic energy of P will be less than kinetic energy of Q, right? Now if velocity of P is less and Q is more, radius of both the shapes are same, then angular velocity of P will be less as compared to the angular velocity of Q. Therefore, omega for P will be less than omega for Q, and according to this, we have our correct option as option number 4. Next, coming to question number 48. Question number 48 says that a hollow sphere of mass m and radius r is rolling downwards on a rough inclined plane of inclination theta. Inclination theta. If the coefficient of friction between the hollow sphere and incline is mu, then the friction opposes the translatory motion. Yes, the friction opposes the rotational motion. Supports the rotational motion. Yes, it will support, because if there was not friction, rotation would not be there. On decreasing friction, force decreases. All of these. Option 1 is correct, option 2 is correct, option 3. On decreasing theta, here it will be theta. On decreasing theta, frictional force will decrease. Yes, this is also true. So all the 4 things are true. So from all the 3 things are true for this question, right? Because you can see from the diagram, here the normal reaction force is equals to mg sine theta. So if I reduce theta, frictional force will reduce. So third statement is correct. Friction supports the rotational motion. This frictional force, which has been drawn in red color, this friction force produces a torque about this center, which helps this body to rotate about this point, right? And the friction force opposes the translatory motion, because the translatory motion is in forward direction. The friction force is acting in the backward direction, so it will be opposing the translatory motion. Therefore, all the 3 statements given over here is correct. Hence, the correct answer is option 4, that is all of these. Next, coming to question number 49. Question number 49 says that a wheel of radius 0.5 meter can rotate freely about an axis as shown in the figure. A string is wrapped over the rim and the force of 5 kgf is applied. The angular acceleration of 10 radian per second is produced in it due to the torque. Then moment of inertia of the wheel. So again, it's simple. It is torque is being given by the formula tau is equals to F into R, and tau is equals to I into alpha. Both the torques are same. So F into R is equals to I alpha. They are asking you to calculate I. So I will be equals to F into R upon alpha. Right. F is equals to 5 kgf, that is I is equals to 50 because G is being taken as 10 into R. Radius is 0.5 upon alpha is being given as 10. So this goes off, you get 2.5 kg meter square. So the correct answer is option 4. Correct answer is option 4. Next question number 50, last question. It says that angular speed versus time of a rod that rotates around one end is shown. If moment of inertia of the rod about its one end is 24 kg meter square, then the torque of the rod at t is equal to 2 seconds. Right. Now here torque is being taken as I alpha. Right. Torque is I alpha, and angular acceleration is given by the slope of the graph omega t. That because the graph which is being given to us is between omega and is being t, so d omega by dt is nothing but slope of the graph, and this is nothing but equals to alpha. Right. So from here we can see that the slope of the graph is, this quantity is 5 and this is 10. So alpha is coming as 0.5. Right. Alpha is coming as 0.5. The moment of inertia is being given to us. They are asking us if the moment of inertia of rod is equal to then torque. Torque. They are asking torque. Tau is equals to your I alpha. I is being given as 224 and alpha is being given as 0.5. So we get tau is equals to 12 Newton meter. Right. The basic concept behind this question was the slope of omega t graph gives you alpha. Right. So once you have alpha, I is being given to you. You can simply calculate torque using the formula I alpha. This t by t is equals to 2 seconds is irrelevant because the slope is constant for all the times, right? So the correct answer for this question number 50 will be option 2. Now let's see question number 30. There was a doubt over there. Question number 30. Question number 29. Yes. So we saw that the center of mass over here was easily calculated using the graphical method. Now we have to see using your components. Right. So what they say, the V-shaped rod can be considered as to be two rods of length L connected at a point, and center of the mass of the rod lies at the distance of L by 2 from the point. Right. Okay. So they are saying that there are two rods and center of each rod lies at a distance L by 2 from the each rod. Now consider the point of the origin. Center of mass of the rod AB is at. So what they are saying that let this point be at origin. So I draw it like this. This is your x-axis. This is rod L1. So this will be equals to this will be L by 2, and again this is the another rod. This is the middle point, mass concentrated, center of mass. This is equals to L by 2, right? Now R1, that is the center of mass of the rod AB, the first rod, let's say, okay, it will be equals to this position. They are telling about this position, this coordinate. This coordinate is, this is equals to 45 degree, right? So this, that is this point, this will be equals to your L by 2 cos 45, sorry, sine 45, here, sine 45, and this length will be equals to, L by 2 sine, sorry, cos 45. So the coordinate of this point is R1 is equals to L by 2 into cos 45 I cap plus sine 45 j cap, right? Similarly, for this, the coordinate R2 will be equals to L by 2 into cos 45 I cap minus sine 45 j cap, right? Because here it will come, right? Now using the formula R of center of mass, M1 R1 plus M2 R2 upon M1 plus M2, putting the values, right? When we solve this, we get your L by 2 into cos 45 into 2 in the numerator upon 2 in the denominator, right? Now this 2 and this 2 cancels out. What we are left with is L by 2 into cos 45 is 1 by root 2. So we get as L upon 2 root 2 is the position of center of mass, right? This is how you get L, position of center mass as L by 2 root 2. So here we end up with the discussion for all the questions for your BPT 16. I hope you understood all the solutions, right? If you fail to understand or find anything confusing or not understandable, that you cannot understand it, please comment in the comment box. That problem will definitely be resolved, right? So good luck for your next exam. Prepare well and do well for your next BPT, right? That is all from my side for today. Thank you.